Hello everyone, I'm sure you're doing awesome. So, this is a completely new series that we are launching today. That is the Spring and Spring Boot fundamentals for the backend developers. And this will be a complete beginner to advanced series. And over here, we will not only cover the Spring and Spring Boot, alongside that, we are also going to cover microservices as well. So, from whom this complete playlist or this course is meant, this is meant for mostly the backend developers. And like after completing this series, you will be able to design, deploy, and understand end to end the production level Spring application, and also understand what exactly happen when we take a microservice application and behind the scenes service discovery, gateway, Docker, the Kubernetes deployment, how everything comes in together. So talking about like why I selected this Spring and Spring Boot as a tech stack here. So this is kind of an evergreen tech stack. Okay, to master the microservice, this if you just go into the enterprise market anywhere, like when I say enterprise applications, be it JP Morgan or the other companies like Gojek, or even the companies like Teradata, the companies who are in data engineering products or travel products, you will see that in most of them, like in the enterprise systems, Spring Boot is still predominant. Of course, in few of the cases, the Python and Golang, this sort of things are coming along, but still Spring Boot is the predominant one. So that is why I have selected the Spring Boot. And once you complete this, if you are from .NET, if you are from Python, or if you are from Golang, it doesn't really matter. The principles which we are going to discuss, like the security principles, the overall principles of the components, or there are the principles of the connecting to the database like the JDBC or the NoSQL, all remain same across all the platforms that you can think of. Okay, so if through this deep dive sessions, if we are able to understand Spring Boot, that means like given any tech stack in the backend, you will be able to excel there. And the prerequisite of this is knowledge on any object oriented programming. Like if you even know C sharp, it is totally fine. You'll be able to understand all the details around the Spring Boot. And maybe a little bit work from your end you have to do is like once the every video is done, you need to just go and do a chat gpt or a Google search, that how exactly this concept translate into C sharp, or how exactly this concept translate into Golang. You will see that it is entirely same, there is nothing different. Okay, and these frameworks are also like always very competing with each other. So suppose there is a certain framework possibility or certain enhancement is being done at one framework like .NET, a Spring Boot eventually catches it up in a month or two, because these are kind of very similar sort of a thing. And so it completely makes sense to master any one of them, and Spring Boot being the predominant in the market makes most sense. So now let's get into the Spring fundamentals and the introduction that we are going to discuss. So how exactly the Spring came into the or the Spring Boot came into the picture in the first place. So imagine we are building a hospital management system, right? So at the moment we are talking about it, there comes like few very basic services that we will need. The appointment service, the notification service, the billing service. There will be a billing team, and there will be a patient service, like where all the patient data will come from, and we can mark it as a repository as well. Okay, so appointment, notification, billing, patient, these are the four very basic primary thing that we can think of. Now how exactly would my code look like while I'm trying to implement this? So suppose there is a primary appointment service code that we are trying to write. And for appointment, like we need dependencies across different objects, right? Like the patient has to put their data, they have to put a time, and also the doctor they have to select. So three basic things they will need: the patient repository, the notification service, and for the billing service for all the money that will be deducted. All these details they will need. Now you see, like when I am using this appointment service or this hospital app, what we are doing is we have to get access to the patient repository. But how we are doing it, like we are creating a new instances of it. For notification service, like in case we are sending the notification to the patient that their appointment has been completed, a separate thing needs to be initiated, again the notification service, and similarly for the billing service. Okay, so these things, if you have worked in little bit around the low level code, you will see like this is a perfect example of tight coupling. Why? So appointment service is hard coded with specific implementation, right? So the moment we hard code with specific implementations, that moment what happens is like we will keep on losing some of the disjointed architectures um, advantages. And if for example here we see the billing services also there, right? So suppose a billing service alongside the patient repository, in future they need to calculate something like a tax, then what we need to do is we need to come to appointment service and also make a change here, because billing service might need uh, another parameter here for tax calculator, because that will be a very important thing. Like the taxation will be separate for the separate region. So suppose somebody is booking in Telangana, or somebody is booking in Karnataka or Maharashtra, so those things needs to be injected here for the tax, for the taxation purpose. Now for that we might need another dependency to be injected here, right? So overall, the way it is becoming more and more tightly coupled or a convoluted system. And also to mention that it is going to be a simple testing nightmare, because if you have written like a single test for any of the application, you know that like while we are sending the notification, this is not a real notification, right? So if we are just initiating the real notification service, so suppose this notification service uses some sort of things like it directly takes to the user's WhatsApp or user's email. But during my unit testing phase, I do not want to do that. So rather I probably would want to do some kind of a mocking across. So with this kind of hard coded dependencies, the mocking will not be possible, and we will not be able to unit test this one. And also, like there are some other problems like the lifecycle management. Like for example, if I have to create a database connection, so every time the patient repository gets initiated, that means newer database connection will be created over here. So it is very imperative that we do not do those kind of mistakes. Rather we should try to find another way to insert this dependencies in some other sense. So if you have understood till this point, I want you to go through this scenario. So suppose your appointment service, the one that we have been discussing, this appointment service need to use SMTP notification in production, but a mock notification service in test. So with the manual creation of the code, okay, so we have the appointment service, okay, in some way we need to have the mock notification service. So with the manual creation of the code, how would you achieve changing this appointment service code every time? And rather than every time, I should have written in the unit testing time. So one of the thing like your answer could be, with this implementation, like there probably will be a flag like if testing mode or something, and there instead of SMTP notification, we are going to do a new up of mock notification. Okay, but this is a horrible implementation. Okay, it is very messy and very error prone. And other than that, like different constructor parameters we can pass, but every time we have to in like pass the hard dependencies. There is no way we could just make it a loosely coupled system. So uh, now with this point, probably you get the idea of a very important concept of the inversion of control. Okay, so what is the inversion of control? Control in a traditional programming sense means that when the objects are created, so suppose the objects are like, so this is the traditional control, like I'm just creating one instance, and on the other side, what I'm going to do is I'm going to tell that you use this particular instance and you call that particular instances method. So now what is the principle of inversion is completely opposite to this. So with IOC, what happens is the framework controls the object creation. So here, as we see, like we have been creating the object under the appointment service. So with our case, no longer the appointment service would create the objects, would create this corresponding object. So this objects that we are talking about over here, like patient repository notification service or billing service, over here, what would happen is the framework tells that you as an appointment service no longer is going to create those objects. Okay, so instead of that, what happens is with inversion of control, the framework tells that I'm going to create the object for you. And how does it look? You are just going to declare what you need. So for example, here the appointment service, this appointment service is going to say that I need this notification service, and here you can see we are using final. And I hope you know like why in Java we require final. Anyway, we will come about this nitty gritty in some point of time. But the idea over here is you only say that I'm going to need this thing as my constructor, injected through my constructor, and Spring will create the rest of the thing. What it will do is it will create the notification service and passes on to here. So it looks like magic, but this is going back to our main question, like why in the first place we are going to need Spring. This is the very core reason. Like this framework provides you a end-to-end way to manage your life cycle of the objects. You do not have to worry about what will be passed and at what time something will be passed, and the whole application is completely the objects of the whole application completely controlled by the framework. Okay, so be it the inversion of this control or the garbage collection, everything will be done by the framework itself. So you see, like this line, this notification service equal to new notification service, this tells a very simple truth that I need a notification service, but someone else have to give it to me. Who will give? It is the framework is going to give it to me. And because the control is now completely given to the framework, the responsibility has been given to the framework to give you that particular object. That is why we call it a IOC, or inversion of the control. The control is now inverted from the traditional sense, from the traditional control to the framework itself. And how is it done internally? The answer is through beans. So what are the beans in the Spring concept? So we are going to touch upon this basic Java concepts right now, and then again we are going to extend upon them with further detail. So suppose yeah, so we started talking about the bean. So bean is a Java object that is created, configured, or managed by the Spring container. So please understand for the time being in a high level. So what happens is like a bean is created, configured, and managed by the Spring container itself. So when your Spring Boot application starts, it scans your project for the classes annotated with component, service, repository, or the controller. So I will just give you a very brief about each of them. So whenever you are marking something as a controller or a REST controller, that means either it is going to serve some kind of a HTTP request, and REST controller means like it is a web API. Uh, if it is a business logic, like over here, you might be wondering, like, while I wrote it like this is a service, and because this is a business logic over here, so we mark it as a service. And the one that talk to database, for example, in our earlier example, we had patient repository, right, which is the repository through the any DDD pattern. If you have ever studied, you will know that this is how, through the generally by convention, through repository we talk to the databases. So now here it would come to the about the repository, about the talking to the database, and if it is any kind of the configuration manager sort of a thing, and those sort of things we mark it as a component. So for each sort of things, it creates a bin or a instance, and it stores in a application context. Okay, so what happens is, like, the moment it sees something, so all the beans, like over here, suppose bean 1, bean 2, like suppose a service, all these things, service 1, service 2, all them will get stored in our application context. Okay, and this happens the moment the Spring Boot starts. So you also might be wondering, like, if I am marking something like a service, for example, like this, a notification service, does notification service is created at the time of the app startup, as we were talking about, like it the Spring Boot application starts and it scans for all the classes and annotations. So the answer is it depends. So by default, whenever we are marking something as a service sort of a thing, internally it mark it as a singleton, one instance in the whole Spring container. So whenever we are marking something as a singleton, so what would happen in that point of time is, if it is a singleton, so then it will be created at the app startup time only. But if there are the other types are there, for example, you can also mark something as a lazy, like you can simply write as service, and then you can mark it as lazy. So what it would do is, it will be useful for the heavyweight beans, and it will opt out from that initialization at the very app startup time that we were talking about, and during the its need, like when exactly it is needed to be injected, that point of time only it will be inserted. And for any heavyweight services, for example, if we have a machine learning model injection sort of a thing, so if we start injecting a machine learning model at the start of the application, it might take a lot of time just for the starting. So in that case, we mark it as a lazy. Okay, so another important point is, like, beans may not be created at all if conditions aren't made. So suppose, like, we are having some kind of a flag, okay, of for SMS, or like SMS is some sort of a feature that we want to give. Suppose that feature we completely disable from our actual application feature store. So in that case, we definitely do not want it to be loaded. So in that case, like, we can have a conditional property, and based on the value we can decide that whether to be loaded or not. So these are the basic scopes, like the singleton at the time of application startup. If I am marking something as a prototype, that service, it means each time it is requested, it will be started. Then if we mark it as a request, that means it is a web specific state. For that particular HTTP request response whole life cycle, it will happen. And if you are marking it as a lazy, whenever on the first time use, it will be initiated. So we will definitely come across these things later point of a time, but for the time being, I hope this part is completely clear to you, like when we are marking it as a service, and what exactly bin is, and how behind the scene, like the Spring framework with this application context manage application context manages the life cycle of this stuffs. So this is exactly the Spring will do, like it will create a notification service, and then it will inject it into the appointment service. So here the appointment service will say that I need notification service, and the bean will provide this. Okay, I hope this part is clear. Like what exactly happens in this whole process, and instantiates internally, like Spring framework instantiates the beans in the correct order. And there is another important thing in this terminologies is DI. DI is nothing but the dependency that is being injected over here that we see. Like you see the notification services that are coming along, right? So the DI is the dependency injection, and so IOC is basically controls the flow, and DI is the mechanism through which framework injects the dependencies. Okay, so I hope this part is clear to you. And another important thing is like we generally declare it as a final. You might be thinking why we marked it as a final. So final in Java ensures that a variable, method, or a class remain unchanged after its definition or initialization. So suppose suddenly another class is calls appointment service, and they won't be able to mark the notification service as null. Like probably someone else would just take that particular instance and try to mark the notification service as null, and because it is private, they and final, they won't be able to change the state of the particular dependency. So it is always important that we should mark the dependencies that we are getting injected through the DI and through the IOC mechanism to always final. So now a little advanced question in this perspective I want you to go through. I want to put some idea into your brain so that these things become a second nature in your mind at the time of thinking, because this is one of the real world scenario. So in a payment processing system, suppose you have a payment processor that needs a fraud detection service, but for a certain given day, okay, like suppose when the Flipkart's that big billion day sale or Amazon's Great India Festival is going on, so at those kind of time, or like we do not really want to go through the fraud detection service, because fraud detection service probably can lead to 7 to 8 seconds of delay. We found that this delay can be detrimental at the time of handling the bulk orders. So let it be, we are not going to do any fraud detection service, and later in the DI engineering pipeline probably we are going to detect some frauds. So during this particular time, we what we want to do is like we want to do a fast fraud detection service, and we do not really want to go through the main one. So in that case, how we can do it? So you just give a little bit of thought by pausing the video. So generally in this case, what we can do is in the implementation we can mark one as a profile, for example as a normal, and another one is as a profile like something like a peak traffic. Okay, so normal will be our public class fraud detection service. Okay, and for the profile, like which is Black Friday, as we mentioned over here, so for Black Friday it would be our fast fraud detection, right? Fast fraud detection service. Now how we can control this is like, this is where the bean becomes so powerful. How we can control this one is in our environmental variables of running this particular application, we can control this profile. So we can always mark the active profile in our application properties, and through the environment or through the environment variables, and we can just inject, and we can just set something like the profile is something like standard, or the profile is the normal, or the Black Friday, something like this. So without IOC, you will need a if else statement to do this sort of things, but you know how clean the implementation will be, completely following the separation of concern, there will be two different classes, and just through the environment variable. So the moment I change my environment variable, I'll be able to I'll be able to pass the profile over here and make the change. So just to look at how the code look like, here we have the service and here we have the profile. So we have this fast fraud detection service which implements the fraud detection service in two profiles. One is through the pick and one is through the standard. So you see, they have different class names, and we are implementing a certain interface, suppose over here, or then what we are going to do is we are going to create another service of payment processor which is going to implement it. And you see, we are just creating an abstract dependency, nothing else. And what we are going to do through our environment variable is, in the Spring profiles active, we are just going to mark it as a pick. So the moment we see that the pick profile is being selected through this export of the Spring of the environment variables, this particular service will kick in for the pick, and this particular will be there for the standard. So this is kind of a feature flag sort of a implementation, also can be done behind the scene like this. So if you know, like I will just write it over there. So if you have further interest in this, like feature flag implementation, you can further study on this. So generally the feature flags in the backend are implemented with some things like this. Okay, so there are couple of things in this dependency injection we should be avoiding. One is the setter injection. So I'm not going to go a lot of details into this, but you must be aware of these things in the setter injection and the field injection. So why do we generally tend to avoid this is because in the setter injection what happens is the objects can be created even before the dependencies are completely baked up. Okay, so why it happens internally like this, I would want you, or I would encourage you to just go through the actual documentations and the other forums to understand this. So the moment we try to do this auto wearing, okay, so Spring calls this setters after the construction. At that point of time, this notification service might not be created. Okay, suppose it is a lazy notification service and for some reason it is not being created, then the null will be passed and your whole application may falter. The same with the field injection. Like, so whenever you are using this auto wired property, okay, be very cautious, and the thumb rule is like we need to avoid this. So if we are unable to avoid, there should be proper justification and proper guard clauses to use our injections, other than like the constructor injection that we have been doing. So far whatever the injection that we have been doing, so that was being called as a constructor DI, constructor dependency injection. So this constructor dependency injection are kind of a immutable because of the final fields. Also, like, it is very easy to test and it doesn't falter like this of partial failure in partial initialization. Okay, so it doesn't falter in those cases. So generally the uh, example that we took, it is the same over here. I will just copy paste it. So this one is the classic constructor injection, and Spring framework will take care of the creation of this object. So here, suppose you are one of the senior engineer and you have been given a class like this, wherever you're seeing a auto wired sort of a thing, but this you must refactor, because the current code, if you see, it is not at all a well testable one, because we cannot really pass any mock here. The second is like, it could accidentally be null by the time we are doing the auto wiring. Maybe the framework hasn't even started it. So it is the kind of how the framework works. The moment it gets into the auto wired, it goes into all the classes, it scans and just return in case it has any object, otherwise it just passes null. So how we can take care of this. We can do a constructor injection, and it is pretty simple and solid to implement. As you can see over here in the shipment tracker, there will be 3 constructor over here. We will mark them, and the implementation of our calculate route will stay totally unchanged. And this is one of the part that I wanted to highlight. This remains testable without even Spring. So you can just use the Java mocks, and using this Java mock, you can test the whole thing. Whereas in this case, you won't be able to do that. So if it confuses you like why it is not testable, just understand this thing. This GPS service, you can definitely mock it here. Like when you are writing your test, that line will compile and run. But because it is a private instance, you cannot really assign the tracker. So this shipment tracker, suppose like here we are creating it as a new object, right? At this phase over here. So how would you use this particular GPS service that you just created into this mock GPS that you created into your tracker? Because the GPS service is a completely private field. You are auto varying it as a private field. A- And now you might say that then I will mark it as a public. So why we shouldn't mark it as a public is then from your this particular bean, you are exposing this property to the world, and any malicious service or any malicious dependency around your code, if it is there, it can actually inject itself to that particular public field, and your program can get completely ravaged out of this. So there can be security usage, and there can be other immutability problems as well, which cut through the heart of the object oriented design. But just make sure that whenever we are marking any internal field, we generally mark it always as a private to make sure that it is not exposed to the outside this class, and then we try to use that particular dependencies into our application. But here, unless we do a constructor injection, what will happen is we will not be used to will not be able to use those dependencies across. As I have mentioned here, although the line will compile, but as this field is private, marked as private over here, so we cannot assign it directly. As simple as that. So in the next part, I'm going to uh, give you the complete end-to-end idea what is happening with the application context and beans and the classes, initialization, everything, how all of them comes together. Okay, so bringing everything together, I am starting from the developer perspective. Okay, so as a developer, when you are running some code like this, when you are doing a Spring application run of a hospital application dot something, it can be any application dot class. Okay, so generally this is the name of the class, as you see, this hospital application, and the same thing we are using it here. The framework generally, like whenever we are using a Spring application, then it automatically gives you this single line creates the application context. So what does it do behind the scene, this part? It creates and refresh the application context through this part. This is the core. It scans the classes. It does a component scan. It does a scan across the services, and then it gets all the dependencies like the class, metadata, and all the dependencies it will store at this point. So this point that you see, this is one of the very important point where we are going to store all the detailed stuff, right? So then there is a dependency graph that is being created. So another important point I want to highlight about this is about this dependency graph. So dependency graph means like notification service is needed by whom. So all the, like class A is going to need B and B is going to need C. So in that way it will know that which context is to be instantiate first, and then through the after getting all the bean definition, it create instantiate and inject all the dependencies, and also something like a post construct that we will discuss in some time. Everything are being fed into the bean instances, and they are being then stored in application context, and it will say that the startup is complete. So all the references, if unless they are marked as lazy, if they are marked as singleton, all of these things are being taken together, and the startup is completed, and the app is marked as ready for the developer. And this beans, what happens is, then whenever we are running a class, any part of the application runs, these are now available for the injection, or like there are methods like getBean that we can use. So I hope that this, with this diagram, it is like crystal clear to you what happens behind the scene. Or if you have understood till this point, then you will be able to answer this question also. So your Spring Boot application failed at startup with some kind of a error. Okay, and like in case you have some prior experience with Spring Boot, you will see that this is one of the most common error that you come across, like the parameter 0 of the constructor in appointment service required the bean of something. So that means, this essentially means that application context scan your code. It found that appointment service with constructor requiring notification service. Okay, and I'm just writing it for your convenience over here so that we all are in the same page. So Spring application context here scanned the code and found that application service, appointment service is going to need the notification service, and it tried to create the notification service bean. That is also true. Like over here, you see, it is telling that this bean cannot be found. So it tries to create that, but what it got is, but the problem it got is, it see that this particular um, bean doesn't exist. So generally in this kind of cases, what I have seen in my experiences, there are some broken annotations are there, like probably we just forgot to mark something with the service or the annotation bean. So yeah, let me copy paste it. So generally this sort of error that we run into is we forgot to mark it as a @service over there. And there can be some other services as well, like although the notification service, for some reason it is not being scanned because it is in some other package. So either it can be this, or it can be another reason, like not in the same package. Okay, so there can be multitude of reasons, but I have seen, like while developer is manually creating some class, it might be something like this that we might run into, where this fix is required. But one important consideration over here is that not all objects are bean. So for example, when we are marking something as just a class, it is not a bean. So over here you can see this particular service, like when we are marking something as an appointment service, this is definitely a bean. Okay, but this is not at all a bean. We manually have to create it, so there is no dependency convenience would be there. So in your service we have to mark it as a regular object. And sometimes, like a lot of utility classes, they do not, we do not really require them to inject it through our dependency injection. So we create classes like the normal objects over here. And there are another important concept over here is the bin hooks. So what does bin hooks means? So I'd like to bring your attention to this particular things, like the post construct or the pre-destroy. So let's talk about what is happening over here step by step. So email service is this constructor is getting called, right, over here at first, and there the email config is injected, and then we have injected once we have injected the email config, all dependencies are resolved and assigned. Then we, like internally, the post construct is going to get called. So now at this point of time, it is completely safe to use, and this tells the compiler or to the runtime that when this whole bean injection is ready, all the dependencies are resolved, then only run this post construct. So this post constructor is something that guarantees that all the dependencies of the constructor, setter or the field are fully injected before it runs. Okay, so this bean hooks concept are very important to understand, that like bean instead of bean hook we can also call it like a bean lifecycle hook. That would be a more correct term to use. So bean lifecycle hooks, they generally controls this part, that once the dependencies are actually ready, then only you use it across. Okay, so now coming into the next part, that is the component scanning that we already talked about, right? So there are some stereotypical annotations are there across which define the different kind of beans. One important aspect I want to touch upon on the component scanning, which I didn't touch in the earlier section, that is this components, what do they actually stand for? So the component, when we mark any class as a component, that means it's a generic bean. So all of these things like a service repository controller or the REST controller are ideally components only, but service is specified for the service layer. That is when we are talking about the business logic. Repository is for the data access layer, and the controller is for the web requests, how they go from the view to model, like we will touch upon the MVC also a little bit. And the REST API is the one when we are marking something as a REST controller. So this generally returns JSONs, and this controllers, this return views. That is the basic difference between these two. So technically all of them are equivalent. Okay, Spring treats everything as the same, but when we are marking something as a service or something as a repository, what happens is it gives the clarity to the developers to understand the architecture better. So it is always better that we mark this component scanning as a we mark this for the component scanning, although we can mark everything as a component, but we should be using the specific annotations. And probably this part is clear, that once these annotations are done, what Spring internally does is it goes through all of the classes, it the application context, and stores them, and whenever as and when needed, then those bean instances are being injected into the application. So in this process, another important concept is auto configuration. So what is auto configuration? Spring Boot is intelligent enough to guess what you need based on what is in your project. So suppose in your pom.xml you have these dependencies. Okay, we will gradually come into all the configurations in a later point of time, but it is just for as a starter. Take this thing into your mind, that the moment you mark something over there under your dependencies, Spring Boot automatically determines what it needs to do in the runtime. So this is also one of the main point. In the runtime, it automatically builds everything as per the requirement or as per the conditional. So here, the moment it sees that the starter web is there, Spring Boot thinks that you are building a web app, and you will probably need a web server, a way to turn the Java objects into the JSON. That is like any Pojo or the plain old Java object you have, you might need to convert them to JSON, right? So for that you need Jackson, and to serve the HTTP request behind the scene, this Java runtime, what it requires is the dispatcher servlets, and there are things like the error pages, the various CSS and the JS files. Everything Spring Boot sets up by itself. So you do not have to configure by yourself, and during runtime, then what happens is, like the code compilations is already done. Post compilation, jars are getting loaded into JVM, and after JVM, then auto configuration, like we just discussed, this auto configuration run, and then what happens is like the beans are created, and then it also goes through the class path, and there are some application property. Based on that, it all the artifacts are created. For example, like if that spring dot starter web is there, that means the dispatcher servlet like the Jackson, all these things will already be embedded across the application. And suppose we have the data sort of a thing, like for JPA, if we use the data source, entity manager, factory, again we will see it probably in our third or fourth video in this series. All these things will be there. If we are having the validation starter dependency, the validator bean will be there. So this auto configuration based on your based on your artifacts. So I will be more clear here. Based on your artifacts, sorry, based on your dependency, it will create all the necessary beans. So all these things are end of the day beans only, right? Like as we talked about, like the dispatcher, servlet, the Jackson to object mapper builder. So all these things will be around your application build. How? It is because there is a convention that we have maintained of mentioning the Spring Boot starter web or Spring Boot starter data JPA. And even if this concept is not very clear to you right now, over the time it will definitely be clear, because we are going to do a lot of example around it, and auto configuration we will touch upon multiple times. Okay, so now before going to the demo or before concluding, let's discuss around this part, like what exactly happened for a REST controller or in a backend flow. So as we are learning this whole Spring concepts from the backend perspective, so there are some front end or some view related concepts are also there, which we are not going to concentrate upon. So mostly we will look all the concept from the backend perspective. Okay. So suppose over here we have a client front-end app and we are making a GET request to this. Okay, and this request will at first go to the embedded Tomcat. So what exactly is the embedded Tomcat in this context? So this embedded Tomcat is comes with the jar itself. Okay, so because we have defined something like this over here as our artifact ID. So with this web artifact ID, unless we specify anything else, Tomcat comes as an embedded server. So what happens is, this there is an important point, that Apache Tomcat is bundled inside your Spring Boot application. It is not installed separately, and the moment you deploy your jar, it automatically runs on that Apache Tomcat server. And of course there are other options, options like Jetty, and then also like there are some things like Undertow, but we have to mention them specifically. Like we have to tell that exclude Tomcat and use Jetty, something like this we need to use at that point of time. Yeah, like our dependencies would look something like this. Like you have to exclude the Spring Boot and you have to include the Jetty. Okay, it will be something like this. So now you see over here we have requested this particular get request will come through, and it will be forwarded to the dispatcher servlet. So dispatcher servlet is the one who keeps on handling any request that is coming from the server itself. So suppose it is listening onto a certain port, and from that port it will forward it to the dispatcher servlet, and this servlet will then put it for the mapping, and this mapper then find out that where exactly it should go to get that particular data. Like over here it tells that if you have to get this data, you have to go to the appointment controller. So this mapping handler would do that, and once it comes to this mapping handler, then it would go to, like from the controller, like suppose if I have a separate appointment service and something, it will go through all the flow, and then it is going to return that particular object to dispatcher servlet. And then it is the responsibility of the dispatcher servlet that it convert it into a JSON, and then it this particular converter or the Jackson. So this all happens internally. We do not have to take care of anything. I'm just explaining so that you understand the end-to-end flow complete clearly. What it does is um this particular library of Jackson then returns you the JSON, and then this particular JSON is returned to your embedded Tomcat through the final client app. So there are a lot of things goes behind the scene, but like right now in few seconds we are going to see a demo application, how the whole Spring Boot and everything comes together. But there you will see that it is not at all a problem. I mean, we can this is completely abstracted by the Spring framework, but understanding what happens behind the scene is very important as a developer, because these are the places things might go wrong. Like sometimes other than Jackson, we might be using some of our custom library and it might throw some problem, and we might see that okay, the JSON is not working correctly. So understanding the detail around all of this component, like embedded Tomcat, dispatcher servlet, like embedded Tomcat, as we talked, that we can even replace with something more lightweight like Jetty. So all these things, that is why as a backend developer we must understand to the core. And also like taking it into a little more advanced topics, like when we are getting into a Docker or Kubernetes. So our containers, like when we containerize this particular app, that suppose the name is app.jar, right? That jar would automatically include the Tomcat. Okay, so like the Dockerized, this is the point, that Dockerized jar would include Tomcat. So suppose you want to change this thing, you can very well change it by this way, right? You can exclude this one and then you can include this dependency over here. So this is I guess pretty clear, guys. What if in this MVC architecture, what if we want to return a view? Then there is something called time leaf that we can use, but I'm not taking those things into the consideration right now, the time leaf and the other view resolvers, because that is mostly for serving the web pages. But Spring Boot predominantly are being used for the backend. So we will be concentrating ourselves into the backend only for the time being. So now that we have covered all the details, I have created a small demo application for you to display what exactly is happening into a basic Spring Boot application. And here I have created the MVC application where I'm even returning a I'm going to even return like a view. For example, like currently this application is running and it looks something like this. This is a hospital appointment system. So now you see, like I am in the home, and it is telling that in which port it is running. And over there, if you just go to the about page, it will give you the about this page, and over here you can see, like when I come, you will say that the about page requested. Okay, so these are the few like what exactly this project does, I will just take you through. So over here you can see, like the first thing is the source. It has all the source code that are being there, it lives here. Okay, and the target is basically the compiled output. So whatever the data that are being like whatever the class paths and everything that are being compiled, it will come over here as a compiled output. The pom.xml, this is a very important file, as you know. Like it has project, all the project dependencies. For example, it is which version, what are the starter project, what is the name of it, the versioning information, and some other details as well, like the uh, time leaf templating, auto restart of the changes, every single details will be there. Okay, so source is your kind of a workspace. The target is like where the Maven creates while building. It never edit the file, so we should never edit any file there manually. Like target, we should never touch by ourselves. It completely gets regenerated every time the application goes into the build and runtime process. And pom.xml, as we discussed, it is kind of a tells the Maven like what are the ingredients by using which we should run. And then also this part is important. This is a wrapper script that let you run all the Maven comments even if the Maven isn't installed in your system. But right now we do not have to worry about this one, this CMD. So the key concept here is, look, this part over here under the source and everything, you can see this is automatically been segregated as per the separation of concern, and the workspace is quite clean. Okay, so now coming into the pom.xml, here you see the project metadata at the top. Like the name is intro project. There is a group ID. It is like a company name. For example, suppose you are working for JP Morgan, like you will see all those application, generally the com.jpmc dot then the application name, and the artifact ID is a unique ID for your application. The version is the snapshot. Currently it is in development, and the name that we have, it is basically a human readable name. And then also we see there is a parent. So what this parent does is, it is like inheriting from this parent class. So Spring Boot provides these defaults, okay, this dependency version and the configuration version, all the things that you see. And then in the dependency section, as you see, like the Spring Boot, yeah, the Spring Boot starter web, that one you see, it includes the Spring MVC, Tomcat, like I think we already discussed about it during our video earlier. So you declare what you need, and Maven as a runtime, then it downloads and manages them. Okay, so the key dependencies, if I could highlight, it is basically the starter.web, it is for the MVC application, and then you also have the timeleaf. So it is basically the view resolver, like for the server side HTML rendering. All the HTML that you see are being rendered over here. They are being done using the timeleaf. Okay, so the dev tools are basically the developer tools, like it supports things like auto restart. We will use it incrementally in our journey, so I thought I will introduce it here. And then also we have the starter test. So starter test is basically for testing, like the JUnit, Mockito, the Spring test, those thing comes over here. So I think you got the idea about the source code organization. So in the standard Maven structure, what we have right now is, so I hope we got this source code organization, like what exactly is the standard Maven structure, how the source, main, Java resources, everything got. But one important thing is Maven follows convention over the configuration. So what exactly Maven does, I think everybody kind of have an idea, but I will just repeat it. Maven is a built time tool. It has nothing to do with the runtime engine. So when we are running something like a mvn compile, okay, or mvn test, in that case, like it turns the .java into the dot class. For the mvn test, it executes the unit tests. So when we run like mvn package, what it does is, like, it bundles your code and dependencies into a deployable artifact. So all this thing happen behind the scene. And how it does it via this pom.xml. It downloads the jar from the Maven Central. So Maven Central have all these details, like the Spring Boot, the Jackson, and other things. So then what it does is, it does the mvn package with the Spring Boot plugin, and it builds the, like, the jar containing your code plus all your libraries and the embedded Tomcat. So all of this thing the Maven does, it happens before even your app runs. So generally, like when we are talking about the production grade application, it happens into the CI/CD, or the build server to be precise. Okay, so now coming into these details, uh, the this why this structure is important is, for the Maven build, Maven follows the convention over the configuration. That is why this structure is super important in our case. Now every Maven project follows the same pattern. So any application across the world, the Java application which is using Maven as their build engine, anyone can look into this, and they will be able to instantly find the things as per this convention. Okay, now coming into the main application class. So the main application class, we have under demo application .java. So here you see we have like, so here we have a master annotation, that is the Spring Boot annotation, and it tells some other stories, like it makes it as a source of all the bean definitions. Okay, and when we are going into the main method over here, so this is a single line, but it does a lot, right? It creates the whole application context, or the IOC container context to be precise, like we discussed for a long time. It registered all the bean it finds, the moment it runs, like it again happens in the runtime, and it starts the embedded web server as well and makes your application accessible on the port 8080. So the moment we are running something like this particular 8080, this guy, this Spring application run, this guy is responsible for this. Okay, now when this is the kind of when we are going into this demo application. Okay, so this is the demo application.java. This is definitely our entry point of the application, and then it goes into the controller. So controller have something like this home controller, and this is the kind of a web layer. And what you see over here is we have used TimeLeaf, and in the TimeLeaf we are returning the home. And where exactly the home is? The home is in our resources over here. As you see, this is the home part. So this controller with this mapping, like when we are hitting the root, it is returning the home, and when we are returning when we are trying to reach the mapping about, it is returning about. So this is pretty much what is happening into the complete flow. So when our web browser here hits the controller layer, it handles the HTTP, and if there is any input, it handles that as well, and then it goes to the service layers. Okay, so in the service layer, what happens is right now there is no code we have mentioned in the service layer or the model. We are just returning it because it is a very introductory introductory um, lecture that we are having. So in the each layer, I will just give you a very basic idea. So controller, it is the entry point for the HTTP request. As you can see here, through this mapping, the dispatcher servlet, after resolving the mapping, it sends these guys to here, and this REST controller or the controller, then after getting the mapping, it send it to the corresponding service layer. And service layer is the part where the business logic lives, and generally it is done with the annotation service. And then it goes into the repository layer, then into the model layer, and we will definitely cover all of this thing in further details when we go into our next videos. So I just want you to get idea around this layered architecture. And when we are talking about this resources directory, so every resources, the visual ones or the CSS JS images that are being packed into here. Okay, so this is basically, there are few static files are there and few templates are being there, which is not of great interest to us, but it is still good to know. And then we have this file of application properties. So application properties is again very important. Like in the runtime, what happens is, like, I can have any value, and I can keep on changing it without making any code changes, or like without any redeploy of my whole application. I can just come into this application properties and make a single change. And what would happen is, this through this like we'll be able to define, for example, this defines our logging level. And there are things like the trace, info, warn, error, those kind of things we can define, which would tell that how verbose the logs will be. And then there will be again the time leaf configurations, as you can see. So there are other formats as well, like even the YAML formats we can use over here. But like again, this configurations we will cover in a much more detail in a later point of section. So I'm going to give this application to you guys in our GitHub repo. So that GitHub repo will be in our comment or the description section in the video. You can get it from there. And how to set this project up, and what are the basic tutorial, what are the basic things that should be a takeaway for this, everything you can have, you can get all the details from here. So this is pretty much it. Like guys, we have gone really deep into the Spring Boot very basic fundamentals. So in our future videos, we will touch upon things like the JDBC, the doing the actual REST controller, the configurations, security, and reactive stuff, everything that we will touch upon. Okay, so see you in my next video. Till then, stay awesome.